All right, today we're going to cover covalent bonding. Covalent bonding is the most common form. It's when electrons are shared. If they're shared equally, that's called nonpolar. Unequally would be polar. And then when you have two atoms or two or three atoms that form a covalent bond, we call this a molecule. So we say, like, for example, water is an example of a covalently bonded, and we would say this is a water molecule, or carbon dioxide is covalently bonded. So this is a carbon dioxide molecule. So we've gone over this before. Anything between the difference in electronegativity 0. to 0.3 is nonpolar, 0.3 to 1.7 is polar, and then 1.7 is ionic. But what does that mean? Oh, here we want to determine. So take the time. Let's see if we can determine if it's polar or nonpolar. So oxygen and fluorine, the difference is 0.5. So 0.5 is going to be polar because it's in between 0.3 and 1.7. Anytime you have the same atom, they're going to have the same electronegativity, so that's 0 in nonpolar. Cesium and chlorine, and already I know this is going to be ionic, and I'll tell you why. Because this is a metal, and this is a non-metal. Remember, any covalent compound or molecule is going to be between two non-metals, right? So the fact this is between a metal and non-metal, the difference is 3.0 minus point. So what is that? 3? So this is going to be ionic for sure. And then sulfur and oxygen, that's a difference of 1.0, so that's going to be polar. Okay? But the question is, what does it mean to be polar and nonpolar? So I'm going to start with ionic. So if you're ionic, let's take the example of cesium and chlorine. So cesium has one valence electrons, chlorine has, let me do it this way. So cesium, chlorine. So cesium wants to give up its one valence electron. So when it gives it up, it's going to become fully positive, and this is fully negative, okay? When they're polars, so in the polar case, say for example you have oxygen and fluorine. What they're going to do is they want to share these electrons. So they have electrons that they want to share. So let's just do it like that. So these are two electrons, or this is one electron that they want to share. Well, what happens is oxygen has a greater electronegativity, so oxygen has a lower electronegativity. Oxygen has 3.5, and then fluorine has 4.0. So what happens is, since fluorine has a greater electronegativity, it'll want to pull on those electrons. So what happens is that this electron that they're initially sharing will get pulled closer to fluorine. So now that it's closer to fluorine, this fluorine becomes more negative. Now the term is, it's not completely negative like chlorine over here, but it's going to be slightly negative. So this means partially. And so this is going to be partially negative. Why? Because the electron has moved closer to it. And then this electron, this is going to be partially positive. So that's what it means polar. It means they kind of have these poles. And then nonpolar, if we have two chlorine, they're going to be sharing this electron are the same, so there's going to be no charge. There's no partial charge, there's no full charge here. Okay? All right. So an example of nonpolar molecules are ones where the same atom are used twice, and there's actually, we call this diatomic molecules. Diatomic because di is for 2. So in nature, these all appear. So there are 7 diatomic molecules that naturally occur. I guess this is a little repetitive. So you have to memorize these 7 diatomic molecules. And different ways you can remember it. Some people remember it as Hofbrinkel. So Hofbrinkel, hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. There are 7 that you have to remember. If I also remember it like this, let me show you. Let me just pull up a periodic table. So this periodic table, the diatomic molecules are right here. So hydrogen's 1, so hydrogen is always H2, and then nitrogen, oxygen, and then these 6. And then if you remember there are 7 that you have to remember, this kind of looks like a 7, so that's how you can remember. So for example, nitrogen always is N2, oxygen O2, and so on, okay? So there's 2 ways. You can remember like Hofbrinkel, or you can remember the 7. But either way, you have to memorize those. Okay, all right, and then we're going to talk about naming molecules. So when things are covalently bonded or between nonmetals, how do we name them? So it's the same as the binary ionic compounds. So the one with the lower electronegativity is written first and keeps its full name. The atom with the greater electronegativity goes second. It ends in IDE. And the difference comes when you have more than one atom. You must name the number as a prefix. So the number of atoms you name as a prefix, except when the prefix is mono. So if you only have one atom, you don't use mono. Let's go ahead and just do some examples. It might be easier. Here are the prefixes that you have to know. So for example, H2O would be named, so we have 2 hydrogen atoms, so it would be dihydrogen, and then 1 oxygen, so it would be monoxide. Notice we take the oxygen and add IDE, just like we did with the ionic bonds. Carbon, this is carbon dioxide, right? So notice with we don't put monocarbon, so whenever the first element, you don't put mono. Anything other than mono, though, you do put dioxide. This is carbon tetrachloride. And then the last one is a little tricky. Remember, these are all nonmetals, and so therefore they get named as molecules. However, calcium chloride is an ionic compound, so we just write calcium chloride. Notice we don't put dichloride. Why? Because we don't use the prefixes in ionic compounds. The reason why I knew this ionic compound is calcium's a metal, chlorine's a nonmetal. Immediately I know that's an ionic compound. Alright, and so you just have to be careful. Calcium doesn't require a Roman numeral. Dinitrogen monoxide, so that means 2 nitrogens, 1 oxygen. Nitrogen monoxide, that means 1 nitrogen, 1 oxygen. And then potassium sulfide. Immediately, potassium is a metal. So with potassium sulfide, this is K plus and then S minus 2. So this would give me K2S. So I have to follow the rules for coming up with the formula for ionic compound. So the difficulty is not naming just molecules, but being able to identify between molecules or covalently bonded compounds and ionic compounds. Here's some practice.